we have to check the continuity of the given functions at 3 points, x equals 1, x equals 2, and x equals 3/2. So we're going to start with checking continuity at x equals 1. So at first we're going to find left-hand limit. That's going to be a limit as x approaches 1 minus of f of x. And at this point our function equals x plus 1. Therefore, when we substitute x by 1, we get 1 plus 1, which is 2. And now we're going to find right-hand limit. That's the limit as x approaches 1 from the right side. And when x is greater than 1, our function equals 3x minus 1. And therefore, we get that our limit equals 2. And value of function at this point is 1 plus 1, and it's going to be 2. Therefore, we get that left-hand limit equals right-hand limit and equals value of function at this point. Therefore, we can say that function is continuous at point x equals 1. Now we're going to check the continuity at x equals 2. So we're going to find left-hand limit, which is limit as x approaches 2 from the left side. So when x is less than 2, our function equals 3x minus 1. And therefore we get 5. Now we're going to find right-hand limit. That's going to be limit as x approaches 2 plus of f of x. And at this point, our function equals just 2. So it's going to be 2. And since left-hand limit does not equal right-hand limit, therefore f of x is not continuous at the given point. At point x equals 2. Now we're going to check continuity at x equals 3/2. Therefore, left-hand limit equals limit as x approaches 3/2 minus of f of x, and that equals the limit as x approaches 3/2 from the right side of f of x, and therefore that's going to be limit as x approaches 3/2 of function 3x minus 1. Therefore we get 11 over 2. So that's the value of the limit, and the value of function at this point also 11 over 2. So therefore we can say that f of x is continuous at point x equals 3 over 2.